Hello, this is Mr. Precella picking up with the second part of my factoring trinomials discussion, which we began a little while ago. And we've gotten up to deciding, okay, if the second sign is plus, the factor form is 2 of the first sign, fill it in immediately. You're going to have to add the outer and inner terms in order to get that middle term. If the second sign were minus, there's going to be 1 plus and 1 minus. I'll wait to fill them in until the end. And you've got to, the last two terms, the outer and inner terms, subtract to get the inner. And that should be a little minus right there to get that middle term. And we're going to see, hopefully the lights won't keep going out. We'll see. But yeah, we're going to start doing some examples just similar to our homework. Right here. The first one we're doing is 2v squared plus 7v plus 5. So let me write that down. 2v squared plus 7v plus 5. Put on colored pens. Now, first thing we're going to do is draw our two sets of parentheses, and I'll go ahead and ask myself, what about the signs? There. And you know what? Just so I can refer to that notation I made. Right there. The second sign is plus. You need 2 of the first sign. So I'm going to go ahead and fill those in right now, because what are those signs going to be? Plus, plus. Second sign is plus, 2 of the first sign. Now this one's different from the first two that we've done, because here the first terms were just x squared, so you just went x and x. Now on this one, there's a number in front of that v squared. There's a 2. So we have to think to ourselves, what numbers multiply together to give 2? Well, there's not a lot of them. 1 times 2, that's about it, isn't it? Now for the last positions, we're going to need to know numbers that multiply together to give a 5. Well, again, not a lot. 1 times 5, that's it. So I'm going to start off putting a 1v times 2v, or the other way around. 2v times 1v, it doesn't matter. I think I'm just going to write v times 2v. Now I've got to figure out, for the 1 and 5, how should I arrange those? Should the 1 go here, or should the 5 go here? 1 and 5, or 5 with the v and 1 with the 2v? Well, to decide on that, I'm sort of foiling this stuff out in my head. Now look at this, inner and outer. I need those to combine together to give us 7v. Well, can y'all imagine if we put a 5 right here, the 5 times 2 would give me a 10v for the middle term, of the inner term, and then the v times 1 would just be a 1v. That wouldn't multiply out or add together to give me a 7v. I'm thinking it's going to have to be like this. Put the 1 here and the 5 here. Again, I mentioned the student that years ago told me you're just making these things work out, and that's exactly right. Yes, I'm making them work out. By putting the 1 here, the 1 times 2v would give me a 2v. The v times 5 would give me a 5v. When I add those together, I get a 7v. So foiling it out, v times 2v. 2v squared. Now here's the outer and the inner, 5v and 2v, that gets me the 7v, and then 1 times 5 is 5. So this, if I were actually on my math lab, I would type in v plus 1 times 2v plus 5. Okay. Let's try this problem right here next. Okay. So I'm going to we'll go back to that second problem in a moment. I'm going to do this one that's number 3. Not that the number really matters, but this problem 3. 2c squared plus 9c plus 9. Okay, so that's the one I'm doing. Well, second sign is plus, so 2 of the first sign. Second sign is plus, so 2 of those, so plus plus. A lot of numbers multiplied together to give 2. There's 1 times 2. And then over here, numbers that multiply together to give 9. Well, there's a couple of pairs, 1 times 9 and 3 times 3. So I'm going to go ahead and start off with this 2c squared. The only thing we can use is 1c times 2c. Or if you want to go 2c times 1c. And now it's a matter of deciding which pair to use for the last spot. Are we going to put a 1 times 9 or a 3 times 3? Which one would make this thing work out so I'd get a positive 9c right there? Well, if we put a 1 and a 9 here, or a 9 and a 1, those aren't going to add together to give a 9c. I'm thinking if we put a 3 here and a 3 here, let's see, will that do it? If I do it, will that give me the plus 9c for the middle? Right here, the inner term, we'd have 6c. The outer one would be 3c. If we add those together, do we get the 9c? Yes, we do. Okay? So c plus 3 times 2c plus 3 would be our answer. Now, why am I circling that? I should instead come right here and write it here in this blank. Now, when I'm actually punching these answers into my math lab, I'll just be typing these in. As a general rule, when you're typing in answers to my math lab, don't hit space keys and don't use capital letters. Okay? Sometimes students get carried away putting space keys, and that messes up the old formatting, and they might count it wrong when it's actually right. So just type it in. If you think to yourself, remember, with my math lab, never hit space keys and don't hit capital letters. This is a lowercase c, use a lowercase c. Don't put a capital C, because you're actually changing the variable then. Okay? Now, sometimes, if you could imagine, if this number here had been 12, then there'd be a lot of different numbers that multiply together to give 12, like 1 times 12, 2 times 6, 3 times 4. So sometimes it might take a long time to figure out which pair of numbers will work. So far, we haven't had many pairs. But there is something that that sort of helps you eliminate some possibilities at times. When you're factoring, let me write it right here. There should be no common factors other than 1 in the parentheses. What the heck do I mean by that? Well, if you were trying this trial and error, if you were doing that, and you had this, 4x minus 8, is there some number other than 1 that divides into both of these? Well, yes, there's the number 2 divides into both of them, and heck, even 4. That can't possibly be one of your answers, one of your sets of parentheses. If you're factoring correctly, there should be no common factors. Here there's a common factor of 2 and 4, so that can't possibly be there. What if we had this, 10x plus 12? Is there a number that divides into both of these other than 1? Well, 2. So once again, no, you can't have that. In general, could you ever have just 2 even numbers in the same set of parentheses? No, because if you have 2 even numbers, then 2 divides into them. Now what about this one? 6x minus 21. Could you have that? No. What number other than 1 divides into both of these evenly? 3. Can't have that. What about this? 6x plus 5. Now, is there a common factor other than 1 that divides into both of these? No. So you could have that. That would be okay to be in the answers. What I'm trying to do is give you an idea of what can't be inside these parentheses. Okay? Like right here, the 2v plus 5. Only numbers that divide evenly into those is 1. So that one was okay. 2c plus 3. Only thing that divides evenly into 2 and 3 is a 1. That's okay. Now, having said all of that, let's try to do this one that we skipped right here. Let me write it bigger. I know it's a little hard to see that. 6x squared minus 5x minus 21. This one's a pretty major problem. I'll draw my 2 sets of parentheses. Sometimes you might be trying something and it messes up. Oh, that one doesn't work. You got to mark it out and try again. Here, you start off. Well, let's see. Second sign is minus. So there should be 1 plus and 1 minus in the parentheses. I'll wait to fill them in. The outer and inner terms are going to have to subtract to get that middle term. So let me just make a note. There should be a plus and a minus. Now numbers that multiply together to give 6. There's 1 times 6 and 2 times 3. Numbers that multiply together to give 21. 1 times 21 and 3 times 7. Well, let's start off. You got to make a choice, either the 1 and 6 or the 2 and 3. Which one do we want to try first? It's a trial and error based process. I'm going to try the 2 and 3 only because I usually try the numbers that are closer together on the number line. I don't usually try the 1 and the number unless that's the only thing possible, like if this had been a 2. So I'll try 2x times 3x. Now, I'm going to try pairing it with the 3 and 7. If that doesn't work, if I can't make it get me a negative 5x for the middle term, I'll then pair it with the 1 and 21. Now, if I can't make that one work out, I'll then say, okay, the 2 and 3 doesn't work. Let me try the 1 and 6. It can be a little tedious. Well, starting off with the 3 and 7. Well, I can't put the 3 right here inside these parentheses, this set of parentheses with the other 3, because if I did, 3 and 3, there'd be a common factor of 3. Okay? Like right here, if you had 3x plus 3, could that be in the parentheses? Well, no, because there's the common factor of 3. So couldn't have that. So just like you can't have 2 even numbers in the parentheses, we could certainly make the statement that you can't have 2 of the same number. You can't have a 3 and a 3. Because then there's a common factor of that number. So if I can't put the 3 here, it would have to go here with the 7 there. Now, so 3 and 7 will give a 21. 2x times 3x will give us 6x. Let's see. Is that better? Is it less glare? Now, let's look at the outer and inner. We have a 9x and a 14x. This is that case where the second sign is minus. Can I subtract those to give a 5x? Oh, you bet I can. If I subtract 9 and 14, I get a 5x. Now let's handle the signs. I want a negative in front of the 5. So that means, maybe I better have that light on. That means the 14 would have, the bigger one of these numbers would need to be negative, the smaller one positive. Positive 9x minus 14x would give me a minus 5x. So that means put the plus here and the minus there. Foil that out in your head and see, are we getting the trinomial we started with? And we are. So let me 2x plus 3 times 3x minus 7. It's possible you might go through all these possibilities and something, you never get it to work out and give you that middle term. If that's the case, you'd say it's either prime or not factorable. They mean the same thing. Let's look at another one. 20a squared plus 19a plus 3. With practice, you get better and better at this stuff. It's sort of like driving. Okay. Let's see. Second sign is plus. So 2 of the first sign. So plus and plus. Numbers that multiply together to give 20. Well, there's quite a few. 1 times 20. 2 times 10. 4 times 5. Numbers that multiply together to give 3. Just 1 times 3. You know what? I think I'm going to go ahead and fill that in right now. 1 times 3. There's nothing else. Now, so it's going to be up to us to figure out which of these pairs of numbers work. Okay? So if I'll start with the 4 and 5 first. So I would try 4a times 5a. How do I know if this one works? Well, I've got to do that outer and inner stuff. I know the 4a times 5a is 20a squared. I know positive 1 times positive 3 is positive 3. But what about this stuff here? We have a positive 5a a positive 12a. Are those adding together to get me a positive 19a? I think they're giving me a 17a, aren't they? So, what will we do? Well, we need to switch the 4 and 5. We could try putting the 5 here and the 4 there. But this first one here, this is not working. Okay? We're getting a 17, not a 19. So I'm going to mark this out, or if you want to erase, and I'm going to draw 2 parentheses and start over. We still have the plus 1 here and the plus 3. Since I'm using ink, I can't just erase the 4 and 5, okay? But if you're using pencil, or if I were doing it up on the whiteboard, then yeah, okay, let me erase the 4 and 5 and switch them. Let's try putting the 5a right here and the 4a there. This is a really good example to show what I mean by just trial and error, and what that student was trying to say so many years ago, that I'm just making these things work out. 1 times 4a is 4a. 5a times 3 is 15a. If I add those together, am I getting a 19a? I sure am. And so this is the factored form. 5a plus 1 times 4a plus 3. Let me see. So I would type in 5a plus 1 times 4a plus 3. Oh, by the way, it really doesn't matter which set of parentheses goes first. I mean, you could sure put 4a plus 3 times 5a plus 1. When you FOIL that out, you're going to get 20a squared plus 19a plus 3. Okay? Let's see. Oh, look at the next one we're going to do is kind of tricky. An expression, a polynomial or trinomial that has a square in it as the biggest exponent, it has a special name. It's called quadratic. And look at the form that these should be in order for us to factor it. We should have an a squared, then the a, and the last thing should just be the number, the constant. Here on problem number 5, it's 9a squared minus 5 minus 44a. Well, that should be rewritten. This constant here, the number should be by itself. So I'm going to write this as 9a squared minus 44a and a minus 5. And now I'll start the way I've been doing. Draw my 2 sets of parentheses. And look, the second sign is minus, so 1 plus and 1 minus. Numbers that multiply together to give 9 is 1 times 9 and 3 times 3. Numbers that multiply together to give 5, well, there's just 1 and 5. So this is another one I think I'll just fill in. A 1 and a 5. And it's going to be up to us now. 3a times 3a. Can I make that work out? So I'm pairing this with 3a and 3a. And if that doesn't work out, I'll try the 1 and 9. Okay? So I would have right here, let's see, a 3a and a 15a This is one of those where the second sign is minus, so the outer and inner term should subtract to give you that middle term. And there's no way you're going to subtract 3a and 15a and get a 44a. So this one isn't working. If I were doing this with the pencil, I'd erase the 3's and say, okay, that can't work. Let's try the 1 and 9 or the 9 and 1. But since I'm not doing it in pencil, I'll mark it out. I'll still put the 1 and 5. And I'm going to try 1 and 9. In fact, can y'all sort of imagine, should I put the 1 and 9 or the 1A and 9A or the 9A and 1A? Let's see. See, if I'm trying to get a 44, I'm thinking putting a 1 here, 1 times 5, no. Let's try it like this. Let's try a 9A here and a 1A, or just A right there. The inner term, 1 times 1A, would just be 1A. The outer is a 45A, 9A times 5. Now those, can I subtract to get 44? I sure can. So if I want a negative 44, that would mean the 45 would need to be negative, the 1 positive. So put a plus here and a minus there. Now when I type in the answer, I won't type in the 1 in front of the A. Here's my answer. 9A plus 1 times A minus 5. Okay. Any questions on that? So we're sort of doing some of this factoring. Let me find some more paper and we'll do another one. The next one we're going to do is let's see, 6x squared minus 5x plus 7. Draw my 2 sets of parentheses. Can y'all see that? Oh, yeah, okay. Well, second sign is plus, so what are we going to have? 2 of the first sign, the second sign is plus, so 2 of the first sign, so 2 minuses. I'll fill them in immediately, like I just did. The outer and inner terms are going to have to add together to get that negative 5x. Well, let's think. What are numbers that multiply together to give 6? Well, there's 1 times 6 and 2 times 3. Numbers that multiply together to give 7, 1 times 7. Only numbers that multiply together to give 7 are 1 and 7. So I'm going to go ahead and put those in right away. And I'm not going to be moving those. I'm going to try it like this. I'll start with the 1 and 7. Try 2x and 3x. If that doesn't work, I'll try 3x and 2x. If that doesn't work, I'll say, okay, 2 and 3 don't work out. Let's try the 1 and 6. So let's try 2x and 3x. Now, how do I mean it? Is it going to work out? Well, you've got to look at this inner. Negative 1 times 3 is negative 3x. And outer, negative 14x. Can I add those to get a negative 5? Well, no, I'm getting a negative 17. So this doesn't work. So let me try. Again, if I would had it something I could erase, I'd just erase the 2 and 3 and switch them. Put the 3 here, the 2 there, and leave the -7 and the -1 where they were. Let's see. Can I get these to add together to give a -5x? Well, I'd have a -2x and a -21x. Is that going to work? No. Okay. This is one where it's not coming fast. So all we know is that the 2 and 3 can't possibly work. Well, I'm now going to put a 1x and 6x instead of the 2 and 3. Let me write that one down. So this one didn't work. That doesn't work. This is called trial and error. You don't always guess it right on the first go through. Let's try 1x times 6x. But again, I'm not changing the -1 and the -7. Let's see. Is that going to give me a -5x? I'd have a -6x, a -7x. If I add those together, I'm getting a -13x, not a -5x. So that one doesn't work. So there's only one possibility left. And what is that? Well, let's switch the 6x and the x. Let's put the 6x here with the -1, or the -1, and the x with the -7. So we would have -1x and a -42x. Are those adding together to give a -5x? No, they're giving a -43x. This one didn't work either. I wanted to make sure that my thought process is clear here on how I did this. I've set the 1 and 7 stationary. I'm not switching them around. And then I'm switching the 2 and 3. Put 2x, 3x. If that doesn't work, reverse it. 3x, 2x. None of those worked, so I'll move on to the 1 and 6. X and 6x, 6x and x. Since none of these work, this one is one where you'll say it's prime. It does not factor. Okay? That one doesn't factor. Let's hope the next one isn't going to be that messy. Okay. Here's one. 7x squared plus 19x minus 6. Well, I'll draw my two sets of parentheses. Let's see. Numbers that multiply together to give 7. Well, not a lot of them. 1 times 7. Numbers that multiply together to give 6. 1 times 6. 2 times 3. Also, I didn't mention, here the second sign is minus. So that means you have a plus and a minus. Second sign is minus, so 1 plus and 1 minus. I'll wait to fill them in. When I'm doing this little outer and inner, I'm going to want these numbers to subtract to give me that 19x. Okay? So let's see. I'll try 1x times 7x. I'll pair it with the 2 and 3. And if I can't get that to work, I'll then pair it with the 1 and 6. Now let's see. 2 and 3. Could y'all do that in your head? If I put the 2 here, that would give me a 14x. If I put the 3 here, a 3x. 14x and 3x isn't going to give me 19x. I'm thinking I should try reversing it. Put the 3 there and the 2 here. That would give me a 21x for the inner and a 2x for the outer. You might be thinking, well, wait, that's giving me a 23, not a 19. The second sign was minus, so you should be subtracting these numbers. Can I subtract 21 and 2 to get a 19? Absolutely. I'm thinking this is how it's going to work out. Well, that means if I'm going to have a positive 19, the 21 would need to be positive, the 2 negative, so that means put a plus here in front of the 3, a minus in front of the 2, and so I'll I'll type in x plus 3 times 7x minus 2. Okay. Let's see. What about this next one? Just sort of flying through this list of problems. It's hard to see the small print. 3c squared minus 8c minus 3. Draw my 2 sets of parentheses. Second sign is minus, so that means a plus and a minus. I'll wait to fill them in. Numbers that multiply together to give 3, just 1 times 3. Well, heck, there's not a lot of possibilities for this, are there? So, let's see. I'll say 1c times 3c. And the only way I can arrange this 1 and c right here is by putting the 1 there. You can't, no, it's by putting the 3 here. If you put the 3 here, remember what we said about common factors? There would be a common factor of 3. You can't have the 3 right here. It's going to have to be a 3 and a 1. If I draw my little inner and outer marks, right here I have a 9c. Right here I have a 1c. I want a negative 8c. I can sure subtract 9 and 1 to get an 8. So make the 9 negative, the 1 positive. Isn't negative 9 plus 1 a negative 8? So that means put the minus there and the plus there. So we'll say c minus 3 times 3c plus 1. Okay. Do one more before we take a break. Write this one down. 6a squared minus 11a plus 3. Well, let's see. Numbers that multiply together to give 6. Well, there's 1 times 6, 2 times 3. Numbers that multiply together to give 3, 1 times 3. I'll draw 2 sets of parentheses. Second sign is plus, so 2 of the first sign, minus and minus. Okay. Second sign is plus, so 2 of the first. I fill them in immediately. The outer and inner symbols, outer and inner terms are going to have to add together to get a negative 11c. Oh no, 11a. Where did I get a c? Well, okay. Which ones do we want to try first? I'm going to try the... Well, first, since 1 and 3, that's the only possibilities. I'm going to go ahead and lock those right there, 1 and 3. I won't be moving those. So let's try the 2 and 3. If I can't get that to work, then I'll try the 1 and 6. Well, 2a and 3a. I can't put another 3 right here because it would be a common factor of 3. So I'm going to try the 3a here, the 2a there. Looking at the inner, negative 1 times 2, that's a negative 2a. 3a times negative 3 is a negative 9a. Do those add together to give a negative 11a? Yeah. So that is it. 3a minus 1 times 2a minus 3. Okay. And let's take a little break right now. It seems like the flashing light problem has been solved. So let's take a short break and then we'll come on and continue all this up, or wrap all this up. Okay. Thank you for watching and listening.